Hi, it's Gadget UK here again. As you can see, this time we're looking at an NEC TurboGrafx 16. I say NEC, it's important to note that actually it was more than just NEC that were behind this. You know, Hudson Soft that produced some great games on the Famicom actually, and the NES. They decided they wanted to get into the hardware side of things, and I think they were the people that came up with the initial concepts and designed some of the initial chipset and stuff, and then they went to NEC, and between the two, you know, I'm not sure what involvement NEC had actually other than the manufacturing, but they may well have influenced the hardware design, because they were you know, a very large manufacturing, you know, electronics manufacturing company. But as you can see anyway, yeah, this is a TurboGrafx 16, so this was the US version of the PC Engine. It's effectively the same thing. I mean, it's interesting, I'll get the PC Engine in a minute, but it's interesting, if you look at this side of the system here, it's got the sort of shape and, you know, that whole, the aesthetics from this side here just look like a PC Engine, and then they just extended it out and then put this thing on the back here, and this just clips off, by the way. Just lift that up there. It's you know, a protective cover. It's got the logo on the back there as well. So you can see the expansion port there on the back. It's a slightly different shape, so I'm not sure what will fit in there. I'm guessing the PC Engine stuff won't accommodate that because of this weird shape on the metal part there. I'm not sure. We'll have a look at that and just compare. But as you can see, just looking around the front here, the first thing that's obviously something that needs to be dealt with is the controller socket there has got a plug. I think that's what's going on. It looks like the end of a DIN plug. You know, it's just the cables have snapped off or something. It's a bit strange. It's can't see much solder on there. I'm not sure what the hell's gone on with that. But anyway, then you've obviously got the power switch on the front there with a little protection thing, you know, that locks your card in, as I mentioned in previous PC Engine repair videos there, so that you can't damage the, you know, the address and data buses and things by pulling a card out while it's on. And the cards that go in here, you know, if you've seen my PC Engine video, you'll already be aware, but, you know, HuCards, I'll show you one of those in a minute. I think by the time, you know, the PC Engine had been, you know, sold as the TurboGrafx to the North American markets and the PAL market, I'll get onto that in a minute, they changed the terminology. Instead of calling them HuCards, they called them a turbo chip, I think it was, which is a bit strange. And the only difference between, well, there are a couple of differences between the two. The data bus pins on the car are obfuscated, you know, they're swapped around, so, you know, instead of going 0 to 7, they're like 7 to 0. So it's a really basic form of copy, you know, region protection. I know it's a copy protection, but it's not region protection. So that if you put a PC Engine card into here, you know, HuCard, you're going to get nothing. It's not going to, you know, the CPU's not going to boot because the data bus is flipped. It's around the wrong way. And as I mentioned in previous videos, you can get certain mods and things to deal with that. You can get adapters, you know, that it's like an inline thing. It plugs in there, and then you plug your HuCard into the adapter, and it swaps the bits around. But also, Game Tech US is a fairly recent place you can get a little mod chip from, and it involves cutting the data pins on the back of the socket there, and then putting a little board on the top, and, you know, and add a wire for a switch or something, and then you're done. You can switch between regions. But also the other thing related to the region protection there is the Japanese systems, the PC Engine, looks for a specific byte or a bit in a byte at a certain address, and I'll post a link down below because there's a really good video. I think it was Jasquadratata, I can't pronounce his name. I'll post a link down below. Check out his channel. He did a video last week making a homebrew cart, you know, HuCart for a PC Engine. One of the things he did to get a US game running on you know, Japanese PC Engine was to change that byte, that single byte in the ROM, before he burnt his ROM, stuck it on a card, plugged in, and it was fine. And I think on the PC Engine you can also do a mod to lift one particular pin. It might be on the 6270, I can't quite remember, and maybe, I don't know, feed it with ground or 5 volts, I can't remember which, but that's a change you can do as well to disable the region protection on the PC Engine, I think. Don't quote me. So yeah, we'll get the lid off it in a sec. You can see the RF port here. It does say there antenna switch, and then you've got, what on earth does that say there? I can't read that. Oh, channel CH3/4. So you've got you know, a switch there to change between channels 3 and 4 for the RF output here, which you won't be using. I thought these had a DIN, but they don't seem to have you know, a DIN as video output, so I'm going to have to use RF initially until I do a mod on this. That's going to be painful. Yeah, so to get in there, we've got 1, 2, 3, 4, 5, 6, 7 screws by the looks of things, and they look like the ones on the N64, Super Nintendo, probably the PC Engine as well. I can't quite remember now. Just trying to cast my mind back to when I did the PC Engine videos. Now, when I did those PC Engine repairs, if you do check those out, the first 1 or 2, there were a lot of mistakes there in terms of referring to chips incorrectly and stuff. So I'll be correcting that when we go through here as well, just to, you know, to reiterate. And obviously, you know, let's say I need to deal with this. So I'll get the lid off, and then I think we'll just try and remove this and just see what state it's you know, it's in inside. So I've got the screws out there. You can see they are, you know, as I said, they're exactly the same size for N64, SNES, I think Mega Drive carts as well. I think is it Game Bit? That's yeah. Anyway, so I've got the screws out. The interesting thing is that the bottom comes off rather than the top. I was kind of expecting it to be this way up and the board to be in there, and it's not. So yeah, that's the first strange thing with that. So it's got this large piece of shielding here. I'm not sure what's holding that on. I think we may need to pull the whole yeah, I don't know, I think we're going to need to unscrew the screws here that hold the board in to get the board out, so that we can then perhaps unscrew the screws here to detach, you know, this from the shielding to release the shielding. I think that's what it looks like. I mean, obviously the 2 screws there to support the HuCard, so you've got a good mechanical you know, hold there, so that, you know, you've not got problems when you're pushing carts in and out. And just a little subboard here for the power. It's a bit weird. You'd think that would just be mounted on the PCB, but for whatever reason they decided to stick a little board there. So yeah, that's a bit strange. Yeah, coming back to the AV side of things, you know, I think you can get like a booster. Is it called a booster or something that just fits on the back that gives you the DIN output for Composite? It may support RGB as well. I can't quite remember. So I might have a look for one of those, because I'm not sure whether I really want to mod the actual case here and, you know, cut a hole and stick a DIN socket and all that, because they are quite rare, especially the PAL ones. Coming back to the whole PAL NTSC thing again, you know, as I mentioned, this was this particular revision here with the, you know, the black case and the extended size and stuff. They were sold to the North American market. In Europe, it was very short-lived, and there were no PAL games actually. The system runs, you know, plays the NTSC games, but it outputs, you know, 50 Hz PAL. Which is interesting. So I noticed myself saying an awful lot in these videos actually, and someone pointed it out recently. So if you're new to my channel, I apologise in advance if you hear me say a fair bit. It's almost like a loading time. So once you've got those screws out, you know, you can just lift the board out here. I'm not sure if somebody's been in this, because can you see the shielding has come off there? I don't know. It could just have been, you know, be cracked, like a loose connection. I mean, it's attached in other places. But I would suggest that maybe, can you see there? Someone's tried to go inside this. I mean, that's broken off there, so it looks like that's been, like, that's impact damage or something. It's a bit odd. So I will be taking this shielding off as the next course of action. So I'm not sure if I'm going to need any additional heat here. I may have to get my desoldering station onto this, because this iron might not provide enough heat, but we'll just add some extra solder and flux, and then just pull that out. I'll get some desolder braid onto that as well, actually, in the solder sucker. But can you see, you know, it's possible to separate that. I just need to, once you've got 1 or 2 of these done, the others are easier to do, because you know, you can't really lift this off at that stage. Really the key at this stage is to making sure I remove that solder. So like I say, I'll get the desolder braid onto there now, suck that up, and then just move on to the next one and just work my way around. So yeah, I've had to get the desoldering station onto this. It's got a bit of a dodgy connection there, so I need to fix that at some point. Works alright when you hold it in a certain position, and then it goes off. And it's not the solder points and things, it's actually the socket is just awful. I think it's just worn. But yeah, this is almost as old as I am, this desoldering station. But that's what I need to get the 450, well, roughly just over 400 degrees here to, you know, heat the shielding. So you can see it starting to melt there now, so that's almost hot enough. Yeah, I think my nozzle's a bit blocked. To soldering pump's a bit blocked here. It's like I've hardly even used it. What tends to happen is you get a build-up of flux and solder in this part here, just where the, sorry, that's a bit close, that, isn't it? Where the, I shouldn't be doing this on the carpet. It's like I get a little bit of solder on the carpet here. This carpet needs replacing anyway. I'm not bothered as long as I don't start a fire. But yeah, just give that a bit of an unblock. Right, so I'll have another go now. It's hopefully unblocked. So hopefully you can see solder melting there. Gradually we can suck that off. Managed to get some desolder braid on there actually. Sometimes some extra heat, as I've talked about in other videos, certainly the other PC Engine I did, you had an extra iron on there, can make a huge difference actually. Yeah, so you can see that's coming off there now. I think it's almost, yeah, that's free. So I'll just work my way around. It's just a bit strange how, sorry, a bit close, that one there is broken and one or two others are the same. It's almost suggests to me someone's been in here and tried to just pull this up themselves. You do have to remove the two screws there from the expansion port in order to, you know, release the top part of the shielding. You can just see the screws there, screw holes from the bottom part. So looking around the board here now, this is some of this stuff's going to be familiar. I'll just zoom in a little bit. Hang on. So you can see the Hudson logo there, the little B, and it's marked HuC6280. That's the CPU, and as I mentioned in previous videos, you know, it provides sound. I'll just talk about that a little bit in a sec. And I/O, it can address 21 bits. It's got a 16-bit address bus internally, I think, but via some bank shifting method there, it's capable of addressing 21 bits on the address there. On the address bus. It runs at 1.79 megahertz and at 7.16. Now, I'm not sure where it switches over, so it changes speeds, and it may well be that, you know, maybe someone can, you know, confirm down in the comments below that, you know, how that works there. But I'm guessing that certain functions it can run at 7.16 megahertz and others at 1.79. It might be when it's trying to address RAM and some of the other chips and things, it gets clocked down to 1.79. No idea. But it's a 65C02 sort of Rockwell based processor internally, but it contains some additional things. It's got the I/O, as I mentioned in a previous video, you know, so your controller inputs go there. It's got sound on board. It's got the 21-bit address capability there. It's also got some block transfer instructions. I think I can't quite remember. I think it's TIA, TDD, TIN, and I think there's another one, TII. I think there's, and there might be one or two others. There's a number of opcodes in there that relate to block transfers. So it was kind of ahead of its time, really. It's, in many ways, it reminds me of the Blitzer functionality you get in the Amiga, you know, in the Agnes chip there, and perhaps the Blitzer in the Atari ST. It's perhaps not as powerful, but this was kind of like you know, an early roadmap of that sort of technology, of the idea of having an instruction somewhere that's handled, you know, one of the custom chips that, you know, you pass it a range of addresses, you know, start address and an end address, and it would copy in parallel to the things going on, or at very high speed, because I'm not sure which it is. I don't know whether that works in parallel to the processing. Probably not. I would think maybe that's where the 7.16 megahertz clock kicks in, perhaps. And I think in the case of this system, it's that instruction works specifically with the VRAM, I think, so that you can copy blocks from VRAM to work RAM. It might go the other direction. I'm not entirely sure. It might be bi-directional, no idea. But it's just worth mentioning that, because that's one of the things that gives this its edge, I guess, you know, the edge that, you know, give it a competitive edge in the market, because the PC Engine and the TurboGrafx were kind of aimed by NEC and Hudson Soft to compete with the Famicom, and I think it did a fantastic job of that. And actually, in the Japanese market, it outsold the Famicom, I think, in the first year or two of sales. I can't quite remember how popular it was, but I just vaguely remember that it was very, very popular over there. It wasn't as popular in the West. You know, the NES really, you know, the Nintendo Entertainment System really sort of got a foothold, really, in the West. But anyway, rambling aside, you know, the processors on these are very good. So coming back to the sound capabilities of this system, the 6280 here provides the sound. It outputs stereo sound, so this was ahead of its time, I guess, compared to the Famicom, which outputted mono audio. But you had 6 wavetable synthesis channels there, 2 of which were capable of generating noise, noise generation. The programmer was not limited to the fixed wavetable. They could change the the sounds for each of those 6 channels there, so that makes the system even more powerful. I mean, 6 channels was ahead of its time as well, I guess. Many systems were 3 or 4 channels at that time, so 6 channels was an improvement. But just the general characteristics of what those channels are capable of meant that you got some really fantastic tunes and sounds and things coming out of these systems. The 6 channels could play samples, and like in other systems, you could merge, I think, maybe 3 or more channels together to get higher bit resolution of samples. I can't remember the exact, I think it'd do like 8-bit, 9-bit or 10-bit or something. It might be 9, 10, 11-bit, I don't know. You could get quite a decent resolution of samples out of there using some clever techniques and things. But yeah, the sound stuff is one of my favourite parts actually of the PC Engine. It just gives some cracking some cracking music and sounds and things on many PC Engine and TurboGrafx games. So the interesting thing is the work RAM appears to be under a little shield there. You can just about see, can you see? Profile looks very similar to these. It's going to be similar size chip. Well, in fact, it's not, it's a bit smaller. It's 8K. We've got 8K of work RAM on these systems. But I'm guessing, that's going to be the work RAM. And I believe these 2 here are the 62256 type chips or equivalent for the the VRAM. So you've got 64K of VRAM on this system, and the 6270 is your GPU. So the interesting thing there is just coming back to the CPU a sec. The CPU's, it's an 8-bit processor. As I say, it's got a 16-bit address bus like the 6502 has, but it's got bank shifting, or bank switching I should say, bank switching capability to address 21 bits. Now the GPU is actually a 16-bit chip. It's got 16 bits address lines. I think it might be 16-bit internally as well, I'm not sure. Yeah, I think it is. It's because I think all the documentation I've read about this suggests that it's definitely 16-bit graphics. Now it needs to be, if these are 32K each, which is what they are, that's 64K. So if you've recently watched my guide to digital video there, you'll know that with 16 bits 64K is the most you can address, and with 64K of VRAM there, it would need to be 16-bit unless there was some way to switch between them there. But yeah, so it's 16 bits. It provides a 9 bits master palette, which gives you 512 colours in total, I think. And I think you can have up to 482 colours on screen at once, which is a hell of a lot of colours actually, and that kind of competes with the Mega Drive, and that's the other interesting point with these systems, with the TurboGrafx 16 and the PC Engine. They were placed to target the NES as a competitor, but actually they ended up sort of inadvertently competing with the Mega Drive and the SNES. I remember, was it Mean Machines or something? I remember reading Mean Machines when I was younger. I think I was at school at the time, and I was like looking through reviews and things like that, and the PC Engine games and TurboGrafx always used to just, I was in awe at the graphics, and they just looked amazing. They looked so arcade-like. So yeah, it's no wonder, like I say, it ended up competing with some of those systems. And the CPU in these, one of the things I've read a few times actually, is that with the good optimization, you can compete. The processor here could almost compete with certain operations in the SNES. So it was a very capable machine. But coming back to the graphics side of things here, the Mega Drive's got 64K of VRAM as well. So this was on par in terms of the amount of VRAM available to it for graphics with the Mega Drive and the Genesis, despite the fact that the Genesis came out later and I think was obviously was a 16-bit system. So coming back to the palette there, out of that 482 colours on screen, it's split. You can have 241 for background colours and 241 for sprites, and I think you can have something like 64 sprites on screen at once, I think. And it supports layers. That was kind of a nice feature as well, really, so that you can have sprites behind or in front of, like, background layers and things like that. And coming back to the VRAM here, if you compare to the Famicom had, I think it was 2K of VRAM, and this has got 64, so, it just goes to show there was, a lot more capability added into this in order to compete with the Famicom. So the final chip on here is the 6260, and this is the DAC. And as I mentioned in my third part, my repair video there, my PC Engine, it's taking, there's a video data bus, I think, between the, sorry, you can't quite see this, between the 6270 here and the 6260, in order that it can send a digital output to this chip, and then this chip is generating your analog outputs, you know, so you're probably going to have RGB composite, I think. So we'll just have a quick look around the board. You can see the fuse there, just like you get on a PC Engine, and a diode. And the diode's going to be for reverse polarity. If you put the reverse, you know, the polarity in the wrong way around, this will short, you know, your whatever input there to ground below the fuse. I'll check that in a minute. It looks all right, I think. RF modulator, your main crystal oscillator down here. I've heard of some people changing these actually to get different frequencies. You know, I read somewhere recently someone swapped one of these out for a different speed in order to lower it to 50 Hertz. Quite why you'd want to do that, I don't know. Those look like capacitor inductor packages or something. You know, they say FL. I'm not sure what the FL designates, but they've got 3 pins, I think, by the looks of things, and they're right next to the inputs there. So we'll need to pull that DIN out in a minute, I think. I don't see any actual damage. I mean, the board's looking a bit dirty. One thing I would say is these are not as nice and as clean, you know, in terms of the manufacturing assembly as the PC Engine. PC Engine was just a little bit tidier. Probably made by the same place, I would think, probably assembled in the same factories. It might just be by the time, you know, they got onto this model, process had speeded up a bit, and maybe they weren't as thorough at cleaning the boards. But when I looked at those 2 PC Engine boards, they looked a little bit cleaner than this. So the next thing I need to do here is remove that DIN. We'll just see if we can just pull that out with a pair of pliers. Hopefully it's not going to come to pieces on me, and it will come off. Yeah, there we go. So as you can see, it's an 8-pin DIN, and that's another interesting point worth mentioning. The PC Engine's got an 8-pin DIN as well, but it's the mini DIN. So, you know, they did use a different you know, controller connector there. The controllers are identical in terms of the way they function. The pinout's going to be slightly different probably, but that was done to control markets, I guess, you know. But that's one problem you can have if you get a TurboGrafx 16. Trying to find the controllers for the TurboGrafx 16 are an awful lot harder than trying to find a PC Engine controller. So I've got a cable. I can show you actually. It's here. As you can see, I've got a 6-pin, sorry, way too close there, 6-pin mini DIN. That's what the PC Engine uses. So I can plug a PC Engine controller in there, and then I just need to wire up a DIN like this. I can't reuse that, unfortunately. It's you know, it's got nothing to hold it. I could put it inside a DIN, you know, plastic housing there, but it's like something's broken off that. It's a bit weird, really. And yet again, a good old 7805 voltage regulator. The interesting thing with the DC you know, requirements on this, on the side it says 10.5 volts. I know for a fact you can get away with 9 volts, and actually putting 9 volts into one of these is better than putting 10.5, and it will work reliably. So it's interesting how they over-spec the voltage there. Not sure why they would have done that. But I do know, like I say, in all the PC Engine models and things I've got here, I've been using a 9 volts power supply that outputs exactly, you know, pretty much precise 9 volts. And what will happen is you put less DC voltage into this, it dissipates less heat. You know, there's less, you know, heat generated as a result of that. You know, the generation of 5 volts down from whatever you put in. So the nearer you get to its minimum working, you know, its minimum required voltage, which is, I think for a 7805 is something like 8.5 volts or 8 volts. You know, the better. The nearer to that, the better. You just generate less heat. I mean, this board is better in some ways, the PC Engine, because you've got more distance between the heatsink here and the chips. You know, the chips are more spread out. I imagine these might be a little bit more robust for long-term use because you've not got everything confined into a really small area. And you know, there is a reasonable distance. I mean, those are about the same distance as they perhaps are away from each other on the PC Engine, but there's more space inside the case for air circulate. Well, air's not going to circulate, but you know what I mean. There's more space in there. The heatsink extends right down on the underneath of the shield in here as well, which means you've got a lot more area there for that heat to dissipate. Having said that, it's going to sort of bake the underneath of the board. You know, there's going to be like hot air sort of developing under there, but the fact there's a giant piece of shielding rather than that small piddling thing you get on the PC Engine means it's better at dissipating the heat. So maybe 10.5 volts coming into this is not really a problem. So before I power this up, I want to work out which connection here is ground just make sure it's the same as the PC Engine. So we'll test from the shielding here to the centre pin, and we've got a short, so it's centre negative, almost certainly. And we can confirm that. See this cap here? That's going to be smoothing the input there. Pretty sure it will, because there's nothing else on this board apart from the power coming in. So if we look at the negative side, the band is down this side of the cap here, going to this pin. So I would guess if we just put this down here, put that on the negative of the cap, centre pin. Yeah, so it's a safe bet that it's centre negative. So something else worth pointing out here, and I appreciate it's not that easy to see, but yeah, the connector's the same. What's not the same is this plastic piece here. You can see this has got, you know, a curved edges here, you know, sort of that shape, whereas this has got these wings, you know, this bit stuck out on the sides. If we were to chop off the top and bottom piece of each side there, that would probably plug in here, assuming there's sufficient travel, you know, in the distance there to accommodate that in the case. You know, that might be the second issue, but you could in theory hack one of these, I think, to plug in there. So I mean, I could, if I wanted to use the, you know, the AV out that I've got on there, the amplified audio and video signals, I could in theory mod that, and I reckon that might fit. I might have to chop some of this off to do that, I don't know, but I'm not going to do that. I'd like to keep this as it is now, because you know, it works, it's good and stuff. If I'm going to get something, do something to this, like say, I'll perhaps get the AV boost or whatever it's called, that fits on the back there. So after a bit of messing about, I've connected the power, got an RF lead. I'll point you at the screen. So I'm going to test initially with blazing lasers. This is the only turbo chip I have, and I have Scott over at, I was going to say the Console Snob, it's not, is it Scott's Gaming Asylum or something, I think it is. I'll post a link down to his channel below, but yeah, he does some interesting reviews. I like his technique of, you know, the way he approaches doing reviews and things is quite open and honest and stuff with his opinion, and he can be fun to watch. But yeah, go check out his channel. But yeah, thanks a lot for that, Scott. You sent this to me, I don't know, about 18 months ago when I had a look at your Neo Geo for you. So yeah, much appreciated. I can now use that. Now the interesting thing with this, actually, when you compare to some of the Japanese games, I don't know if this one's got good box art. Yeah, it has. Some of the Japanese games have got really nice box art. They come in these little sleeves, by the way. You know, obviously they come in like a CD type case, and you get this little clear plastic wallet here to protect it. But the artwork on Japanese cartridges, or HuCards, is very generally very nice. You know, there's a lot of love gone into the art on there. If you compare, as you can see, they're exactly the same, but many of the TurboGrafx 16 cards have these really basic, just text, you know, an icon. There's not much else on them. That's one of the things that appeals to me about the Japanese variant. Interestingly enough, this turbo chip says HuCard on it, so I don't think they really knew what they were doing with the naming standards there. You know, they tried to market it as something different for the West, but it was only ever going to be a HuCard, I think. I think the largest these will hold is up to 20 megabits. I think there's one or two games that have got some sort of save RAM or something, or they were supposed to have, and I'm not sure it ever actually materialised. Populous is one of those. I talked about it a little bit in one of my earlier PC Engine videos, but I don't think that card has actually got anything on it. It was intended to have it on it, and it was stamped on the back to say it had some additional save RAM or something, but I don't think it did. It used, you know, it needed the save RAM that was built into some of the other systems and things there. That was a recent purchase, actually. You can see this is one of the arcade Duo cards there that allows my Super CD-ROM 2 to play some of the arcade games. I think that's the only card you need with that Super CD-ROM 2, actually. Some of the other CD systems, you need you know, different versions. Well, it depends what game you want to play, but you know, if you get something like this, you can pretty much play everything. I think that's got most of the memory that you need on there to play some of certainly the arcade stuff. But there's different tiers, I guess. You know, I think there's the Super CD stuff. You need a certain amount of memory for that. Then there's the arcade stuff that needs even more memory. And as you can see, that's actually working. Obviously here I've missed a step out. I've got a HuCard in there. Well, not a HuCard, a turbo chip, whatever you want to call them. It is a HuCard. It actually says HuCard underneath it, despite the fact it's classed as a turbo chip. But yeah, it's working. I've tried to fine-tune it, and there's no sound. I'm guessing this is the NTSC version, actually. You can hear, got no sound at all. So I'm guessing it will be NTSC. It's going to be on the different audio subcarrier frequency or something. So I'm not sure how to approach getting the video out of this actually, and sound. I did have a quick look at the turbo boosters on eBay, and they're like £100 just for unboxed. £100. That's just absolutely insane. So I might just end up running a couple of fly leads out the back or something. I'm not sure. I'll go away and have a think. But in the meantime, I'll clean up the board and stuff. Perhaps show you some of that, reassemble it. I need to make an adapter for the controller and just test the controller port works, so I could perhaps show you that. There might be a second part to this video, I'm not sure. We'll just see how I get on with it. So thinking about this, there's a couple of possibilities. C140 here sort of couples the composite signal, I think, to the modulator. Now, reading the service manual, it says measure the voltages on these 3 pins here, well, the pins 1 and pin 3. This first pin, I get 5 volts. Up there we get 2.2 volts. Now it does say that should be between 0.8 and 1 volt. And if you're getting anything other than that, swap out the modulator. So I think the modulator is probably the fault. There's some SMD components. I'll zoom in a little bit just so you can see. A load of SMD components crustily soldered in there. I don't like the way they're soldered in actually in places. They're just like tons of solder. Like here, there's a massive blob of solder there to a small blue component you can just about see there. But there'll be through-hole components. You can see some of the connections here, on the other side. Chances are the modulator perhaps just needs a recap, but it could be that C140. So what I'm thinking of doing is I might just desolder the centre pin from here, from the RF connector if I can, and then just run a wire. I'll find the relevant side of this cap here where the composite signal goes out, and I might just route it straight there so we've got composite coming out of here, because no one's going to use it with the modulator anyway. And as I said earlier, I think it's the NTSC variant this, so the sound's on a different subcarrier. So in the UK here, I'm not going to be able to use it no matter what, unless you've got a TV that'll accept proper NTSC modulated signalware. And whilst my TV will actually display the picture, well, badly, it won't display the audio. So I then might, put, I don't know, 2 fly leads out the back or something, so I don't have to drill holes and things. I might just be able to squeeze it out of the side, of here or something. I'm not sure. I did also, for just disconnect the power, I did also investigate further this here, because I wondered, sorry, I zoomed in awfully close there. I did wonder if we could take this metal piece off. Maybe we would then be able to just plug a normal expansion in there, but that's not the case. The plastic is moulded the same shape with these angled bits here. So you gain a tiny bit by removing the metal bit, but not a lot, not enough. And like I say, I don't want to hack the booster I've already got. I could always purchase another booster for a PC Engine and just hack the plastic part on the booster. I may do that yet. Right, well, I'm glad my brain sort of took me down that route of thought actually to try and use this, because I just inspected closely. Can you see this? We've got a crack here. I think what's happened is this has suffered an impact. That was why the 5-pin DIN was stuck in the front. It might have fallen off a shelf or something like that with things connected. Someone may have left an RF lead plugged in, left a controller plugged in, or an extension or something for the controller, and that's why the controller bit was stuck in the front. And I think this is why this is fractured. I think this end of the case perhaps hit the floor maybe, and it's cracked there. So I'll scratch this area here in the solder mask, and then just put some flux on there and solder that whole thing to join it back up. That should give us a slightly better picture. I think we're still going to see the purple speckles and the lines and all that. I think in part that's because when we turned over to digital here in the UK, I've found, and I could be wrong, quote me below if you know otherwise, but I've found that anything that uses RF, as soon as we switched over to digital, things are interfering with it. I think there's things on the similar frequencies and things. I'd be surprised if something was on the frequency this is set to. Is it 61 megahertz or something, somewhere around that region? But still, that's one of the things I've found since the cut over to digital. Anyway, we'll scratch this off. Let's say get some flux solder over it and give it a try. Incredibly hard to film and show you this at the same time, but I'm just using this pointy tool here. Incidentally, this was something I was just telling Miss Madeleine about in one of her videos in the last day actually, that this tool, you can see how sharp the tip is there. It went through, this is a number of years ago, 20 odd years ago, 25 years ago, it went through my thumb there, and came out this end here of my knuckle, about that distance. It was like straight through the centre of my thumb. If you imagine it was like that. I pulled it back out and went into shock. Yeah, so be very careful with pointy tools. But yeah, the technique, like I say, is just, I don't know, you can still see this, just to scratch the solder mask off so you can see the copper on both sides of the brake here, as near to the brake as possible, so that all you see is copper over the broken area, and then just get some flux on there and just solder, put some solder over it, and that'll join the two back up, and it should hopefully be reliable. I still think we're going to get an awful picture, as I say. I have no delusions that it's suddenly going to be a nice clean RF signal. I think it's going to be the same, but one of the things I was finding is that I put the RF cable in, couldn't get a signal at all. There was just nothing. I was messing around with it for ages a few minutes ago, trying to get the thing to come back on again, and that was the point where I inspected and found the crack. So you can see there I've soldered that point, and it's given me some stability. Obviously the picture's awful, but you know, the connector now, doesn't matter how much you mess with it, it just works. So that was one of the reasons why when I first powered this up and stuff, it did take me quite a while to tune it in actually. I don't think I mentioned that, but it did. It took ages to actually find a picture. So I thought about this, and in order to rule out the DAC side of things and the transistors and things, I think I'm going to do what I suggested, which is remove all the solder from around that centre pin. Hopefully there's no components there that I'm not going to be able to separate. The brake actually in the PCB might help me, in the sense that it'll be isolating the rest of the modulator from the the centre pin here on the RF connection, and then I'm just going to join a wire to the composite signal. I just need to work at the best place to take that from, and it might be one of these positions on this cap here on C140, I'm not sure. That's what I might try. I'll just have a look at the schematics first, just to see where the composite signal goes on the back of the expansion here, because that's what I've used in the past, to feed composite out. But I'm guessing it's going to be connected to the transistor that drives the composite signal, and it's probably going to be, let's say, one side of that cap, I think. So a wire coming from here through the little gap in the modulator cam there, straight to the centre point, put the lid back on. That's the video sorted, and at least I'll be able to see whether I'm getting a nice clean picture, which will give me an indication that the DAC's okay, and as I say, the amplification of that signal is okay as well. That, it'll prove those things. Yeah, it's no surprise, as soon as I've heated the pad up there, you can see that's the pad. The pad obviously has got nothing to hold it on, because it had cracked at the point there, and it's just come off, so it's not a problem. I mean, someone could join that back up there, that wouldn't be a problem. You could just bend that over a little bit or use a bit of wire and join the two up, but the fact that the pin is not connected to anything there, that's perfect. That's exactly what I need. The alternative, of course, is to remove this. That's one thing I did think about doing, is removing the modulator completely and putting a DIN on the board here, or a mini DIN or something, but then I'd need to make a cable up. A DIN's better, because then I can use my existing cables that I use with the PC Engine. But I'm just going to, let's say now, just join a wire, and where I need to go is R126, I think. It's probably this little resistor here. I need to just check on the multimeter, but the positive side of this cap is going to connect to one end of that resistor, I think, if that's the right one, and then the other side of that resistor is the composite signal. So it's going to be the side that's not connected to the positive of this cap. So I'll just test around with the meter. Yeah, so just testing continuity. It's not this resistor here, I don't think. Let's just check that. One side is, one side we've got a short there. Let me just check the other resistor, hang on. That's a short, the other one isn't. The other one's a lowish resistance, that's a dead short. So it's R127 by the looks of things. And then the other side's got a resistance, obviously, because it's a resistor. But that's a dead short to the positive of the cap, I think. Let's just try it again. So there we go, it's joined up. It could be a bit longer, that wire, just to fit a bit better, but to be honest, that's not too bad, I don't think. Can flatten it a bit like that, and this should just fit back over there without crimping it. Let's just give that a go and see whether we've got a clean composite signal. So powering on. Wow, what a difference. Now bear in mind I've not got a cap in line there, but it probably doesn't actually need it. I mean, that's the normal composite level, composite signal that would go to the expansion connector. It's probably a good idea to put one there. I might just do that. I might just remove the wire from the resistor and stick a cap in series with it. But it looks fantastic actually. Considering it is just composite. So all I need to do now is just fly 2 wires out the back for the audio, I think, and should be good to go. So yeah, I'm totally cheating here. Temporarily, I think what I'm going to do ultimately is get one of the little amplifier boards and mount that in here. And I'll perhaps take the bottom shielding off when I do that and route it underneath. But as you can see, I've just attached a wire to the first pin and the third pin down the left hand side. That's I think the one nearest to us is the left, I think, and that one's the right. I can't remember if there's the wrong way around. I'll just check that in a minute, double check it. But as you can see, I've got 2 short wires coming off, and then what I'm going to do is solder to the positive of the cap, solder the wires here, or the centre wire, to the negative of the cap, join the grounds up to the nearest ground, which is probably down here. It's the easiest thing because it's got solder on it already, but encapsulates those caps there in some heat shrink, and then maybe do something with the cable relief. I don't think I'll need a cable relief because the wires are going to come out through here, through the gap, so I know we're very close. Let me just see if I can zoom back a bit. But the screw fittings here will accommodate, I've tested, will accommodate the wire just coming out like that in the case, so I can have 2 wires coming out from one side. So it's a temporary thing. There's nothing professional about it. You wouldn't want to do things like that and sell them. But for my testing purposes, it's it's just going to solve the problem really, just get some sound out. But it does need to be amplified because the level that comes out from the chip there, and it needs to be certainly protected at least by a cap, because you're coming pretty much straight out of the CPU there. There might be something in between, a transistor or something, I'm not sure. I think there possibly is. The other thing to point out while we're here as well, you see this area of the board here that's not populated. It's marked UPD 65006, and again there's a space over here for a dip chip marked 23C1000E. So that's going to be either a ROM or an SRAM, I think. I'm just wondering, and this could be for the SRAM. I'm just wondering if this was a facility that they considered to add the save memory support. I don't know what size chip it was it 2K or something? I'm not sure whether that was the intention of both of those, or it could have been maybe to stick the CD-ROM on there. I'm not sure, the BIOS there for booting the CDs, that could have been a possibility at some point in their mind. I'm not sure, but I would suspect that that's for save RAM, and it was just never implemented. But you can see how dirty the borders around there. So we'll be cleaning up all of this area certainly, because you don't want flux and stuff over those connections there. I am wearing an anti-static wrist strap at the moment, by the way, because I shouldn't be touching the board otherwise. And some connections here, can you see there's like flux or something all over here as well. They just do look very dirty, these boards, but any areas like that I'll focus on. But right now, like I said, I'm just going to finish off doing this. So there you go, you can see it all joined up. You can hear sound in the background. I'll just point you at the TV in a sec. But yeah, I just need to heat the heat shrink now to get that to shrink, and then route this, like I say, inside the case. Some glue or something might be an idea, I don't know. This is, just bear in mind, this is temporary really. Ultimately, like I say, I will get a little amplifier board in there and route it properly. But the main thing is, like I say, it's working and I'm able to use it without, like I say, any permanent changes to the system. Certainly the case, that's the thing I'm worried about really. I don't really like cutting holes in cases. I guess the final step here is just clean up the board in a minute and then clean up the case. So I've cleaned around this area with some cotton buds and just up here a bit. Not gone over the entire board because these boards have just got loads of flux. If you look at it in the right light, you can see like a browny sort of residue over everything. But I thought it was worth pointing out a few of the things that I've done as part of the diagnostics here when I first came to power this up. When I was getting no TV output at all, check the 7805 here, just make sure we had 5 volts on pin 3. Pin 1 is your input from your DC jack, which in my case is 9 volts. I think that measured a bit lower actually, probably from the voltage drop there. It was about 8.7, 8.8 volts, but on the pin 3 here, the one nearest my finger, 5 volts. So I knew the 5 volts was there. The other thing you could do if you're not getting video out of one of these is try and get audio out of it. Now obviously you need to tap the audio off. You could measure from underneath the pins there. On the expansion slot to see if there's audio there, but you could just attach some wires temporarily and connect it to an amp or something, a bit like that little box I showed in the ZX Spectrum what's it called, Cura Microspeech, you know, that little amplifier I got there from Alice and Shells, something like that. I was thinking of getting that out and just attaching a few wires just to see if I could hear any sound, because you know, I wasn't sure whether there was something wrong with the video side of this at that point. But yeah, just messing around with the connector seemed to resolve that, but it did take quite a while to work that out. And then obviously beyond that, you know, you need to do things like checking clocks and stuff just to see if you've got any activity, or get your data, you know, your logic probe onto the data bus on the CPU. Is that the CPU? I can't even read it from here. I think it is. Can't quite remember now. Yeah, get the you know, your logic probe onto the data bus and the address bus of the CPU, just see if there's any activity. Because I wasn't sure, like I say, what was going on. You know, I did wonder if you know, the impact had suffered, because it did seem to have suffered an impact certainly from the DIN connector and the crack we've seen there. Whether there was something broken, you know, crack on the board or something like that. I mean, there was ultimately inside the modulator, but that wasn't really what I was expecting. I was kind of expecting something else, if I'm honest. So it's worked out quite well, this. I haven't had to swap any of the chips or anything. So it hasn't needed the full sink clean, actually. All I've been doing is just wipe over it with some soap and water. But these little white marks, I'll see if I can show you, get a bit of this Maguire's plastic stuff, shown it 1,000 times. These, just gently, you don't need to put any pressure or anything, just rub around a little bit in different directions. It is a textured surface, so maybe a little brush would help with this. Now bear in mind, you can see the wet bit. It's because it's got like an oil, you know, it leaves a residue. But once I've cleaned that off, it will look good as new. The mark has it, well, it's almost gone. I just need to do a bit more there, still a little bit, but you will see it will disappear completely. Got a little one there as well. Let's just give that a little go. So apologies, it's going dark actually, you're not going to be able to see very well, but where the shielding had been broken off here, you can see I've just started to scratch around here to expose the copper. I'll just go a bit further down here towards the bottom, and then that whole lot will be soldered to join it back on. Right, so we've got a really crude diagram there. You can see the cable, I did show this before. It's got the 8-pin mini DIN socket here. I've got the wires stripped and twisted the ends. We'll tin those up. And then next I'm going to solder this connector here for an 8-pin DIN, and it's the circular type of thing, you know, also classed as a horseshoe. You can see it looks like a bit of a horseshoe with a centre pin as well. So I've spent a bit of time looking at the schematics and stuff for this. I did find a diagram online that reinforced the fact that the pin mappings are direct. So if you take pin 1 on the mini DIN side here, it does correspond to pin 1 on here. You can't see it, but actually textured on the surface there of that connector are the numbers. So yeah, I've been able to confirm that, like I say, against a diagram I found that was the opposite way around actually. It was for converting a TG16 controller to plug into a PC engine. I want to do the opposite. I want to plug my PC engine controller in here and then plug this end with the 8-pin DIN here into the TG16. So yeah, the mappings are just straightforward. It's pin 1 to pin 1, pin 2 to 2, 3, 3, etc. until you get 8 to 8. So it's quite straightforward in that sense. There's no swaps there between pin numbers and things. The numbers, you can just go straight off the numbers, pin 1 to pin 1, 2 to 2, etc. So it's going to take me a good 10 minutes at least to do this. But yeah, what I need to do, like I say, is tin up these wires, because you can see the strands are just, you know, coming out there. You need to twist them all up, make them as flat as possible, and then just tin them, and then it should just be a case of pushing them into the relevant holes here, add some solder and flux. I'm not going to bore you with that. There's plenty of videos showing that sort of thing. In fact, I'll perhaps put a link in the description above or down below in the comments to a recent video of Miss Mad Lemons. So anyway, I'll be back in a sec. So there are benefits to buying pre-made cables like this, you know, ones that have got half of the connectivity you need. So this, you know, had the right mini DIN connector on there. I've had to open it. The only way I've been able to do that, to get it off there, is to cut the plastic surround off this here. You can see I've cut it down now, tried to make it as smooth as possible, so that it goes right up to about that point, and then I'll put a piece of, this goes over there by the way, so it goes, the covering will go, slide back up to about this point here, and I'll put a piece of heat shrink tubing over it and heat shrink it. It'll look really professional when I've done it, that won't be a problem. But I've had to open this because I couldn't find what colour pin 4 was on this connector. There was just nothing, and the ground was not connected to anything either. And you're not going to be able to see this, but just looking inside, they've trimmed off the ground down to that level there and the brown wire. So even though it's an 8-pin DIN, they've only wired up 7 pins and solder as a fully wired 8-pin DIN. So I'll be complaining about that. Actually, that's really annoyed me. The good news is, because the ground, you can just about see here, it's just exposed, I can get some solder on there, attach a little wire, join it back up, and use the ground to pass it through, because the brown wire's trimmed right off here, you know, and I'd have to start literally, you know, I'd have to probably cut all those wires off and re-strip them all, tin them all, stick them all back on. I can't be bothered with that. But the ground is easily available here. You can just see a little bit of it, so that'll be really easy, super easy to join a connection up to the centre pin. It does mean that the centre pin is shielding the whole cable, which I don't like, but to be honest, the short distance this cable is, it'll probably be okay, but strictly speaking, the shielding should be connected to the ground. There's not a lot I can do about that really, other than just, like I say, trim it off here, reconnect it all up. I don't really want to do that. They're quite fiddly to solder these, which is one of the reasons why I got a one pre-done really, half the cable that I needed, so I just needed to stick the DIN bit on, the large DIN, not the mini DIN. Yeah, so thinking about that, I changed my mind. I started to think having one of the signal lines acting as the shielding was not a good idea. And I went digging around, and I just found, you can just about see here, found the brown wire. So I've just been able to pull it out a little bit. I'll put some solder on there, some heat shrink and a wire, join it up to where it needs to go, and then the ground I will connect at this end here to the the outer part of the connection there, just to make sure it's the cable is screened. You know, you've got proper grounding around those cables there. But yeah, you know, I've looked out with that really. That's going to save me a lot of effort. But I do need a piece of heat shrink because it's awfully near to this shield here. I wouldn't want it to make a connection, but it should be okay. I think I can recover that. So I'm not going to deny that was a bit of a pain actually, but you can see I've got a small piece of heat shrink there, just joining the brown up to a new white wire. It's a bit bigger. I've had to flex it inwards a bit, and in order to do it, I actually had to remove the yellow and the green, because you just couldn't get any, there's no way you can get soldering iron into that centre pin. But that now means that all 8 pins are joined up, so I can slide, put the plastic parts back on here first, slide this over, and then like I say, I'll just put a piece of heat shrink tubing over the end. I'll show you that in a minute. So actually it doesn't need any heat shrink tubing. You can see it's holding it together. That's it could be straighter, I could have cut that housing a bit straighter, but it grips, you can't pull it off. So I think that's okay. So I'll just test that pin 4 now, just to make sure I've got connectivity. So I've changed the grey covering out there for a black one. It should fit the DIN okay. I think they're all pretty much the same. They have the same gap there for the flap. But yeah, put this on first, because that's something I nearly always forget. Got it right this time around, thank God. So all I need to do now is, like I say, because I know which colours my wires correspond to. Now 4's brown. Now I've fixed that. It's just a case of just wiring up these numbers here to the connector here. So I'm on the final part now. Just put this on, slide the cover over, and we're done. I'll join the ground up to here. I might just solder it on actually once I've clipped this together. The best advice I can give you when doing something like this is do the centre pin first, because like I explained when I had to disassemble the mini DIN, I had to take a few of the wires off in order to get access to the centre pin, and it was a bit like this with this. So I had to remove the red in order to give myself space to put the centre wire in. So in retrospect, I should have done the centre wire first. The other thing is these pins get incredibly hot when you're doing this, so something like those little helping hands, you'll have seen them on other videos, those can help a lot. But just too much heat, especially if you're using helping hands, any kind of force at a certain angle, the pins can melt. The plastic can melt because of the temperature the pins reach. So what I would recommend with that is, what I do is, damp my finger after I've soldered, damp my finger quickly, and then just touch the pin. You'll hear it like a singeing noise as you help cool the surface there, or a wet sponge or something. You could dip it into a wet sponge, but just be mindful of the fact that any pressure on these pins at that point when you're heating, you can alter the alignment. They can bend all over the place and stuff. But I mean, I haven't had that with this, because I always, let's say, lick my finger and stick my finger on there till it burns, so my finger's actually hurting now as a result of that. But yeah, I don't envy people doing these. They're painful to do, they really are. I hate doing the things. So yeah, not some of my finest work, but it's functional, that will work. So as I say, not some of my finest work there, but you can see connected up, PC Engine controller connected up. I'll show you, we are actually using PC Engine controller here. Excellent. So So yeah, I can use all my PC Engine controls with this now. Fantastic. I'll get the EverDrive onto this and we'll just load a few games up. So I thought we'd do a size comparison there. I did say I was going to show you the PC Engine next to the thing. So I mean, it's not quite, you know, I had sort of envisaged that this was literally just the same thing chopped, but they've stretched it out a bit, you know, and obviously the little indentations have changed to accommodate the aesthetics there. But yeah, you can see it's very, very similar. You know, it's just like I say, they've elongated it and stuff, and obviously moved the connections and things around. But the TurboGrafx 16, yeah, they're a lovely system. I do like the shape of it, despite the fact it's larger. One thing worth pointing out, this temporary thing I've done here with these leads, you know, it can't accommodate the thing on the back there because of where they're coming out. So I mean, if you're going to do something like, which I may do, mount some proper nice RCA sockets, RCA jacks, maybe one on each side or on the back somewhere, you need to think careful about the power connector there, because you don't want to cause a problem there. Maybe this side's a bit better. You may even have to, can you see that hole there for the power? That's designed for the power lead. You may have to put a little slot on the other side if you're going to do something like that, but thinking about it, maybe it wouldn't be a problem putting a couple of connectors on here, because there's no other solution really. You know, I can't put the back on now, and it's, you know, but it's just temporary really, just to get it up and running and to demonstrate that it works and stuff. So we'll give the EverDrive a go now. You can see here this is a 2.4, I think. You've got a switch up here that says PCE TG16, so we just need to just slide that up carefully. I think that should be it. Hopefully we've not damaged it with the SD. That's one thing I don't like about the EverDrive, actually handling it. You know, got to be careful, try and not touch any of the connections on it. So plug it in, bring the screen, switch it on, see what happens. That's a good sign. At least we've got the menu up there. Hopefully be able to see and hear why I love the PC Engine so much, really. Yeah, it's a very capable system, it really is. Graphics, fantastic, excellent use of colour. You know, they look very colourful and vibrant, TurboGrafx and PC Engine games. Let's start. I love the music on this game as well. So it's got some cracking tunes through the various levels here. Different, you know, unique tune per level. The idea on this one is you've got different types, you know, flavours of power-ups. That V gives you like a spread shot, and if I click some of the V, as we'll see in a sec, you get more distribution there on your spread shot. And I think there's a further level to each power-up, so we get another V. That's like a little pod. You carry two pods, you can see it circling the ship there. Those are quite good, and you can detonate them to pretty much kill everything on the screen. If you get a different letter like that L there, it will change your weapon to the lowest level of that particular type. Something like L is laser, F's flame. It's a very good game though, it's very fun. That's the missiles, you can get that, use that with any of the weapons. So you can see I've got heat-seeking missiles there now. That's the second pod, I've got two now. Skip that, jump up the third V, and I'll just show you something else. I just got to the boss actually, just so you can see the boss. I might edit it, just so you don't get bored watching all this. There's the third V. There you go. So that's maxed out with this particular weapon. I can detonate a pod and then collect another one. And that's the tactic really. Try and keep two pods all the time, and whenever you get a new one, you know, you see one there to collect, detonate the one you've got. Very cool game though. So I couldn't not show Operation Wolf again. Any opportunity I have to show this game on the PC Engine, I will take. It's absolutely fantastic port, it really is. I love this version. It just feels so close to the arcade, I guess, from a home ports perspective. Just tons of love put into this port, really. Bonk's Adventure, can't not show this really. I think there's 2 or 3 of these games at least on here. I've not played many of them. They're good though. There was an Amiga version of this, wasn't there? Was it BC Kid? I think it was, wasn't it? Can't replay this now. There you go, you've got to bonk. What the hell is it? Oh, there you go. Yeah, button 2. Yeah, absolute classic. Parasol Stars as well, another absolute classic, one of my favourites. Splatterhouse, what an awesome game this is as well. I quite like the spin-off actually that came out for the Famicom. It's like a cutesy sort of version of the same thing. I've been playing that a fair bit recently. Ordine here. This is another great shmup. Love the music on this, it's simple. Yeah, great game though. Even has a great port of Shinobi, actually, this system. Very arcade-like. So overall, I'm quite pleased with the result. You know, as I say, this is just temporary. I will get an audio amp in there, maybe do an RGB mod at some point, I think, unless I can find some solution, you know, to plug something in the back there, maybe mod that. If I'd spent some time recapping the modulator, I suspect we could have got rid of some of the band in there and the purple lines and things on the RF, but it was kind of like a futile, pointless thing to do really, because this is an NTSC model. I'm fairly sure it is. The sound is on a different subcarrier. We couldn't use this. Couldn't use it on a TV anyway, and nobody's ever going to want to use it on RF. I certainly don't. Just for the point of going, oh look, it was the capacitors. You know, here we go. This is how you fix a modulator. No one's going to be bothered about that really. So it was just useful, I guess, for me to do the mods and things while I've done. You know, I've done in order to be able to test this. And I guess maybe the one thing that's useful in this video is just the tips, I guess, on producing something like this, so you can, you know, make your own adapter for one of these. Because as I said earlier on, the controllers for the TG16 are quite rare, you know, rare as hen's teeth, whereas PC Engine controllers are much more commonly available. There's actually tons of these on eBay, you know, the different coloured ones. You can get the Hori ones and stuff. There's all sorts of different pads and sticks and things available for the PC Engine. Anyway, hopefully you found that interesting. Thanks for watching. I'll see you soon.